Hi, the objective of this 7th video on synthetic division is to convert a number written in base 16 to base 10 with the synthetic division. I'll be using the C language for this tutorial. A link in the description will take you directly to the work page. This is a work page, a wikibook. You must first download the hash files. You can find here the hash file. You can then download the first example, a C file. This is the example, a C file. I copy this file into my editor. I must verify if I have all the hash file. Yes, I have all the hash file. I save my C file. Can you help me to convert a number written in base 16 to base 10 with the synthetic division? Yes, I can. Using this method, you can quickly convert a number written in base 16 to base 10. In fact, if a number is written in base 16, for example, D, A, 17, 8, with D equal 13 and A equal 10. This number worth this value. This number in base 17 is equal to this value in base 10. You must first create this polynomial where you put d here, x power 3, a here, x power 2, 7, x 8. Okay. Now you must write the good value for d equal 13, a equal 10, and 7 is 7, and 8 is 8. If you give the value 16 to k is viewed in the last video. If you give the value 16 to k, you have this polynomial. In fact, I put an x7, 16. There is therefore the evaluation of a polynomial. If I want to know this value, I must evaluate this polynomial. It is the remainder of the synthetic division. The synthetic division gives this value. I have already saved this example. Using this method, the synthetic division, you can quickly convert a number written in base 16 to base 10. In fact, if a number is written in base 16, for example, D, A, 7, 8, this number is worth this value. You must write this polynomial, with the coefficient are given by this value, D, A, 7, 8, and when you evaluate this polynomial, you have this value. This is therefore the evaluation of a polynomial. You must evaluate this polynomial. It is a remainder of the synthetic division. This is the polynomial, this polynomial. This is a polynomial D, A, 7, 8. I have decided for K the value 16, and here you can find the algorithm of the synthetic division. Okay. Here you have the coefficient of the polynomial. You copy this value here, and then you multiply this value by 16. You have this value. You add these two values. This gives this. You multiply this value by 16. This gives this value. You add these two values. This gives this. You multiply this value by 16. This gives this. Now you add this value, and you find this, and this value is the good value. Okay. Now I want to try another example. I copy the code into this line. Using this method, the synthetic division, you can quickly convert a number written in base 16 to base 10. In fact, if the number is written in base 16, 1, 5, A, C, F, 7, this is a number in base 16, this number worth this value. Okay. Alors, in first I might create this polynomial. For the coefficient I use the value of the number in base 16, 1, 1, 5, 5, A, C, F, 7, 7. Okay. Now I give the good value for A, C, and F. Alors A 10, A 10, C 12, et F 15. Now I have my polynomial, and I give the value 16 to K, and this gives this polynomial that I must evaluate. I must evaluate this polynomial. There is therefore the evaluation of the polynomial. All the work give this is therefore the evaluation of a polynomial. It is a remainder of the synthetic division. If I use the synthetic division, the remainder is this value. Okay, donc I have copied the new example into this file. Alors, using this method, you can quickly convert a number written in base 16 to base 10. In fact, if a number is written in base 16, example 1, 5, A, C, F, 7, this number is worth this value. You can write this polynomial, and if you write this value in a base 10, this is in base 16, in base 10, this is therefore the evaluation of a polynomial. It is a remainder of the synthetic division. This is a polynomial that I have right here, with the coefficient of this value. I copy all the coefficient of this polynomial in the first line. 1, 5, 10, 10, A, C, F. This is the coefficient of the polynomial. Now I copy this value here. I multiply this value by 16. This gives this. I add this value with this value. This gives this. I multiply this value by 16. This gives this. I add this value and this value. This gives this. I multiply this value by 16 here. I add this value and this value. This gives this. I multiply this value by 16. This gives this. I add this value and this value. This gives this. I multiply this value by 16. This gives this. I add this value and this value. This gives this. I multiply this value by 16, and this gives this. And I add this value and this value. And this value is and this value is this value. And this value is this value, the value that I want to compute. It is a P of 16. This is a remainder of the synthetic division. The objective of this video on synthetic division is to convert a number written in base 16 to a base 10 with synthetic division. Thank you.